I'm Zongbo from Tianjin University. It is my honor to introduce our work, Multimodal Dynamics. The outline of the presentation is organized as follows. We introduce the necessary background and related work. Then we present the motivation and the proposed method. Finally, we show the experimental results and conclusions. Multimodal learning aims to integrate information from different modalities to improve learning performance. For example, in ambient intelligence for hospitals, we need to integrate information from multiple sensors, including cameras, depth sensors, and other potential sensors. In robotic applications, we need to combine visual and tactile information to make decisions. In practice, multiple multimodal applications are safety critical. In multimodal medical diagnosis or autonomous driving, if the decision of the intelligence system is wrong, it may bring serious negative effects. This inspires us to utilize multimodal information in a more elegant way to produce trustworthy multimodal fusion. To improve the trustworthiness of the intelligence system, uncertainty learning hopefully makes a deep learning model be able to say, I don't know. Another related work is to calibrate the confidence of the model output to match the performance. Some works focus on uncertainty in multimodal data. For example, the contribution of different modalities to decision-making may vary dynamically. In this paper, we employ a confidence-based model to assess the informativeness of different modalities for each sample. Dynamics exist in multimodal data. For one modality, the informativeness of different features may vary with the samples. Meanwhile, the informativeness of different modalities may also change for different samples. In multimodal medical data, as shown in figure, uninformative features and modalities widely exist due to the unsatisfactory data collection. Example, inherent noise in multiomics data, uneven quality of histopathological images for different patients, and tabular data with complex missing patterns and feature noise. This motivates us to evaluate the informativeness of each feature and each modality of different samples, and conduct a dynamical multimodal fusion. Traditional multimodal methods mainly focus on obtaining a joint representation by exploring the correlated and complementary information between different modalities with powerful neural networks. In this work, we propose a novel algorithm termed multimodal dynamics for trustworthy multimodal classification, which models the feature and modality informativeness to promote the fusion stability and explainability. The framework of the proposed method is shown in the figure. We introduce a sparse gating strategy to dynamically obtain the informative features for different samples, and the modality confidence is introduced to dynamically evaluate the informativeness of different modalities for different samples. Accordingly, a unified multimodal fusion framework is introduced to dynamically fuse informative features and modalities, and to reduce the influence of noisy features and modalities, endowing the model with robustness for dynamic variation of quality for features and modalities, and trustworthiness for the final decision. We conduct extensive experiments on 4 real-world multimodal medical datasets. To investigate the improvement of the multimodal fusion strategy, we compare our method with 5 single-modal classification and 7 state-of-the-art multimodal classification models. Firstly, we compare the proposed methods with state-of-the-art single-modal and multimodal classification methods on multi-classification tasks. The proposed method outperforms other methods on most datasets. We further conduct comparison experiments on the binary classification task. The proposed algorithm achieves 1.7% and 2.3% improvements over the second performer TMC in terms of accuracy and F1 score. We also conduct qualitative analysis to intuitively investigate the superiority and effectiveness of the introduced feature informativeness and modality informativeness modules. We investigate biomarker identification and drug target discovery by interpreting the feature informativeness of the multiomics data in our multimodal dynamics. Then we visualize the obtained multimodal informativeness. Overall, our contribution is the following 3 points. Firstly, we propose a novel method termed multimodal dynamics for trustworthy multimodal classification. Secondly, the proposed method evaluates both the feature-level and modality-level informativeness for different samples and thus trustworthily integrates multiple modalities. Finally, extensive experiments are performed on 4 multimodal medical classification datasets, where our method achieves superior classification performance and enhances trustworthiness and explainability. Thank you.